Hi everyone, and welcome back to another episode of Dr. Guile Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going through the subatomic particles and the size and mass of atoms. If you find value from the content, please make sure you hit the subscribe button and give the video a thumbs up. Let's go ahead and jump in. Okay, so the size and mass of atoms. Atoms have a radius of about 1 × 10 to the minus 10 meters, or 0.1 nanometers. Now, if you're unfamiliar with using the terms 1 × 10 to the minus 10, so this section here, this is called standard form. And so what this essentially means, very quickly, is that 1 has been divided by 10 times. So, for example, if I took the number 1 and I divided it by 10, I'm sure we would know that equals 0.1. Now you could also write this as 1 × 10 to the minus 1. If I then took that 0.1 and again divided it by 10, that would be 0.01, and so I could write this as 1 × 10 to the minus 2. And so all this number just here means is that the 1 has been divided by 10 times. Okay, so the radius of a nucleus is about 10,000 times smaller than an atom. So it has the diameter of 1 × 10 to the minus 14 because it has been divided by 10 a further 4 times, hence why it is 10,000 times smaller than the atom. Okay, so the majority of the mass is inside the nucleus. Right, really important table here that is fundamental to the rest of the chemistry GCSE. So I've divided up the table into the subatomic particles, protons, electrons and neutrons. Protons have a mass of 1 and they have a charge of positive. Now I remember that by knowing that P for positive, just over here, P for positive, P for proton. Now going down here I have neutrons, which are neutral, and then the last one is the electron, which is negative. Well done if you already know that. Okay, so some key definitions now. So the mass number is the sum of the protons and neutrons in an atom. The atomic number is the number of protons, which is equal to the number of electrons in the atom. So an example here is lithium. Lithium has the mass number at the top of 7 and the atomic number or proton number at the bottom of 3. Now, I always tell my classes to remember this by remembering that the biggest number is the massive number. And that then reminds us that the mass number is always the largest, the massive number at the top, and the bottom number is the one left over, the atomic number or proton number. So this number tells us here, all these numbers, PEN, protons, electrons, neutrons, show us that we have 3 protons, and if we have 3 protons, we have to have 3 electrons. And so now, if we know there are 3 protons, and we know the number at the top here, the mass number, is the sum of the protons and the neutrons in the atom. So 3 of that 7 is already protons. We simply do 7 minus 3 to work out our number of neutrons, which is 4. Okay, so I've given a few examples here for you to now have a go at your leisure. So pause the video now, have a go at them, and then we'll go through the answers. Okay, brilliant. So boron then. Proton number is 5. If you have 5 protons, you have to have 5 electrons because atoms are neutral overall. So you have to have those 5 positives and 5 negatives. And you simply do 11 minus 5 to equal 6 neutrons. Aluminium, we have 13 protons. If you have 13 protons, you've got to have 13 electrons because you've got to have an equal number of positives and negatives to make them neutral. And so 27 minus 13 is going to be 14 neutrons. Carbon on the side here, protons 6, electrons 6 because of the proton number at the bottom, and then this one 666 for protons, electrons, neutrons. Really well done if you got that right. Okay, so the last bit I want to look at is the key definitions of isotopes. Now, an isotope is an atom with the same number of protons, but a different number of neutrons. So if you look at chlorine on the periodic table, you'll notice that it actually has a mass number of 35.5. Now, obviously, you can't have half a proton or half a neutron, so something else must be going on. So what scientists do is they take an average of all of the isotopes of chlorine. Let's have a look at the table in a bit more detail to see what these isotopes are. So, chlorine 35, chlorine 37. Protons 17, 17. They've got to be the same because the atomic number of chlorine is 17. That's what makes chlorine, 17 protons. Electrons, 17, 17 again. If that was different, it would be an ion, and it's not. Neutrons, 18, neutrons, 20. Now remember, it's an isotope because the same number of protons, but a different number of neutrons. That means, of course, that the mass number is now different because chlorine 37 has 2 extra neutrons. Atomic number is 17, 17, the same as the proton number, because remember the atomic number is also known as the proton number. And now the last bit down here is the abundance. Now abundance means how much there is of something in terms of a percentage. And so in the example of chlorine 35 and chlorine 37, you have 75% of all chlorine in a swimming pool would be chlorine 35, and 25% of all chlorine in the swimming pool would be chlorine 37. And so scientists work out an average of both of these isotopes to then give an average number of 35.5 just here. Now I'll show you in the next slide how to do this calculation. Okay, so the way to remember this and to be able to work out the mass numbers using the isotopic values and the abundance values is a little jingle. Mass times abundance, add it all together and divide it by 100. And so what that means is your mass, 35, times your abundance, 75, plus your mass, 37, times your abundance, 25, mass times abundance, add it all together, and we divide it by 100. You will find, and please have a go at this on your calculators to make sure you can do this, it will come out as 35.5. Okay, so what we've gone over today is we've identified the mass and charge of protons, neutrons, and electrons. And we've described what an isotope is and how we work out the average mass from the abundance number. Thank you very much for watching. Please do give the video a thumbs up. Tell your friends about the channel to learn science content, and do subscribe to the channel to give more content straight to your mobile device. Thanks very much. Bye-bye.